So for saving the chart, you can do a save image as or a copy image, or we can use the save fig function in this uh, plt.savefig. You can mention a PNG file, a JPEG file, a PDF file, okay, any of the image files that you want. So let's save this figure as a PNG file. You can give a complete path. If you don't give a path, it will save where your current file, the current IPYNB file is there. It will save there. So before doing a save figure, we will also call the function tight layout so that this particular legend is correctly saved in this PNG file. If you do not use the tight layout, then what happens is that this layout, only half of this layout would be saved. Okay, some part of this legend would not be saved correctly in the PNG file. So once you run this, okay, and do this before the show, because when you call the show function, that is the point your PLT initiates back to its level where all these settings that you have done, all these are gone. So we need to do it before you call this show function. So let's see the PNG file. So this is the way this particular chart is being saved. Okay, you can very well use a JPEG or a PDF, any format that you would want your file to get saved onto. Now let's suppose you want to plot emojis. We're not plotting emojis directly, but we're using the Unicode characters to see how to plot the emojis. Okay, and you can use a wide variety of Unicode characters using this particular method. You can use any, you can print, you can use markers of, you can use any markers which are Unicode characters. Okay, and the Unicode characters, you can plot the Unicode characters using /u. So you can search for a character map app on your laptop and you see any of these Unicode characters. If you note the keynote, okay, Alt 0174, these Unicode characters, you can, the character set has to be Unicode here, okay, and this is this Unicode. So this is generally the keystroke that we use, and this is the Unicode character which is assigned, okay, to each of these markers. So the copyright sign, the right sign, and so on. So we are going to use the Unicode emoji to plot in this particular chart. So let's do plt.plot and let me use np.arange 10 and I'm just multiplying it by 2. Okay, so you would get this particular smooth line, or you could have used the same x and y coordinates that I had used earlier. Okay, and we could have got these particular lines. Now let's say I use the same x and y, and your marker here. So for Unicode marker, you will have to place them in a particular way within the $. Okay, and then you will have to give. So basically, it's a scientific notation which we'll cover in much detail later. So this is $, and then /u is for Unicode, and 263A is the Unicode marker. And it's quite small. Let's just increase the size of this. Okay, and you would see this particular smiley emoji. All right. Now suppose you want to change the color of the emoji. This Unicode things mostly you will have to change the not the face color but the edge color. So there is a property called marker edge color. So it changes the color of your the edge part of it. And generally for Unicode characters you wouldn't be able to change the face color, because though it looks like a face here, but it is just the edges which are being drawn actually. Okay. Similarly, you can open your character map and suppose you want to print this particular Unicode character. Just click on that and check out what is the Unicode here. So this is the Unicode 221A. Okay, and you can get that particular Unicode character. It's quite interesting, isn't it? Another very interesting marker, okay, is about multidimensional polygons. So this marker actually, it's a tuple. Okay. The first argument in the marker tuple is number of sides. The second argument is what kind of symbol we want, and the third argument is the angle. Okay, so we'll see an interesting example of this marker. Suppose you say I want number of sides to be 18. Okay, and the symbol is 0, 1, 2. Let's suppose I want the symbol as 2 and the angle is 35. Okay, and let's make the marker size to be a little bigger. Okay, so these are this marker, it has 18 sides. Okay, and this is the style of the marker. So this is an asterisk kind of a style, and these are the angles within these. It is rotated by these many degrees. These particular edges are rotated by 36 degrees. So this angle between the edges, and the style, it just takes 0, which is default. It takes 1. Okay. So this is a particular star like symbol here. If you just reduce the size, it will look like a star. Okay. And the third one looks like an asterisk. So there are 3 possibilities, 0, 1 and 2. So you can have the marker edge color and the marker face color here. So since there is no face to it, we are not getting the face. So let's ignore this property for a moment. And let's suppose we just want, so this the pentagon, the P, like, which is a pentagon, hexagon. So we have all those directly with us, right? So those are 5. Basically, internally it uses this tuple. How many sides that you want, what is the type of that marker, and what is the angle between them. So I leave it up to you to explore it further to create some wonderful marker styles. So similarly, you can have, so suppose we have this marker which is a hexagon. Now let's come to the multicolored polygons, the third part of our topic in the basics. So you would notice that this is basic as well as advanced kind of stuff that is going on hand in hand, and this is the way the entire course will be covered. Now in this multicolored polygons, let us first just plot it using a hexagon, and let me use these two properties, the marker face color and the marker edge color. And I'm using these colors just to showcase, because I mean they are not aesthetic in nature here, but I want to showcase how they would look like. So this is the blue face color and you have this edge color, right? Now in this, what you can do is you can color this polygon into multiple colors. So there is something called as a fill style. And as you dig deeper, what you will find is each and every property, as I have introduced, each and every property is customizable. So you can say fill style is left, and once you say fill style is left, then you can use the marker face color alt, the alternate color. You can use this property, and let me use the alternate color as green. Okay. So the fill style is left, it is taking the face color on the left, and the other part is colored green. Okay, so this is your multicolored polygons. This fill style, okay, it could be left, right, top, bottom, none, and solid. Sorry, it's a full. The default which we are seeing solid is a full. So left is like this, and let's suppose I'll just show you one or two more. If you say top, then you will get a top, bottom. This is the bottom fill. You can also increase the marker edge width. And this has become just too big. So let me make it 2. And you can get this width. You can increase the marker edge width as well. So for the basics, we will stop here. And in the next section, we will jump to how to chart pies. Okay, the pie chart. We'll see the pie chart. And most of these things that we have studied today are applicable throughout matplotlib, like your X label, Y label, the title, how to save a particular figure. Okay, great. Things which are repeatable, I may or may not probably be taking it, for all your charts. But here on, for all the other charts, we are going to see the properties which are important properties for that kind of charting. But you should keep all this in mind, that you can create wonderful charts using matplotlib.